Hello, and welcome to this tutorial on phylogenetic tree construction as made for MIMG 109BL at UCLA. This first video is on the outputs of Sanger sequencing. By the end of this video, the student should be able to interpret and judge the outputs of Sanger sequencing, understand the use of Mega software, and construct a library of FASTA files for further analysis. The common output for Sanger sequencing is called an electropherogram. An electropherogram is a graphical representation showing the results of sequencing data, indicating the position of a nucleotide base and the strength of the signal at that position. On this electropherogram, you can see the DNA sequence above a series of peaks and valleys whose colors indicate one nucleotide base and whose heights reflect the reliability of detecting the indicated base at that position. Using your background on how Sanger sequencing works, consider why the signals are not particularly strong or distinct towards the beginning of the sequence. This is generally the case for the end of the sequence as well. We can continue with our analysis by trimming off these sequences with ambiguous signals using Mega software. In order to start trimming your sequences, first open up your version of Mega software. Mega stands for Molecular Evolutionary Genetics Analysis, and it is a commonly used tool for sequence analysis and phylogenetic tree construction. I will be using Mega 7, but the process for trimming is the same for Mega 6. First, go to Align, Edit or View Sequencer Files Trace, and from this window select the Sanger sequencing output in an AB1 file that corresponds to the sequence that you are trying to trim. From here, you should be able to see your electropherogram in a new window. Starting at the 5' region, select where in the sequence you'd like to end trimming. I'm going to trim everything before nucleotide position 90. This is where most of the signal ambiguity ends. Highlight that nucleotide and click this button to mask everything upstream of the cursor. Now, repeat the process for the 3' end. Use your best judgment to interpret the reliability of the electropherogram. I'm going to trim everything above position 700 by highlighting that nucleotide and selecting Mask downstream of the cursor. All of this sequencing data will be saved for alignment and for phylogenetic trees. Go to Data, then Export as a FASTA file. Using the appropriate name and output file, save your trimmed sequence and view it in a text editor. Your FASTA file should have your trimmed sequence and your header region. This header line is customizable as long as you have this caret, so you can rename the sequence, add the length of the sequence, or even a brief description if it helps. You can also start building libraries of FASTA files by collecting all the sequences in one text file. Now repeat the process for the rest of your isolates. This ends this first tutorial on phylogenetic tree construction. Thank you.